All right, so chapter 5, we're going to talk about the mathematics of chemistry, and in particular the mole and chemical formulas. All right, so here's kind of the outline. We're going to do counting atoms by weighing, counting molecules by weighing, so the difference between atoms and molecules, mass percent composition, and then using percent compositions to determine empirical and molecular formulas. All right, first let's talk about this concept called the mole. All right, the mole is just a word. All right, it's a word that represents the number of something. All right, just like if I were to say to you 1 dozen, what does that mean to you? If I say a dozen of eggs, a dozen of donuts, what does that mean? Well, that means 12. When I say the word dozen, it means 12. Well, all this word means is the same type of thing. It's the same analogy. 1 mole should, in your mind, be 6.022 times 10 to the 23rd. That's all a mole implies. It's this many of them. It doesn't matter if it's a mole of quarters, if it's a mole of shoes, if it's a mole of atoms. When I say the word mole, it implies this number right here. And this number is Avogadro's number. All right, Avogadro was a scientist in the 1700s, and basically they gave him the name because he kind of, in a way, he came up with it. Okay, so if I ever say the word mole, or this term mole just implies 6.02 times 10 to the 23rd, or 6.022 times 10 to the 23rd. That's all this word means. Instead of saying a dozen, okay, we just say the word mole. Okay, so here's the actual information. They talk about that they gave the honor to Avogadro, and basically how they found it. We're not going to talk about how they found it, but pretty much if you count out exactly 12 grams of carbon, you will have exactly 6.022 times 10 to the 23rd carbon atoms. Okay? So the numbers of atoms are determined by weighing a sample, and the number of atoms per unit mass depends on the types of atoms that we're talking about, called the molar mass. Okay, the molar mass is the mass of 1 mole of a substance. So if I have 1 mole of a substance, all right, of anything, let's put X, there is a certain mass to it. All right, there's a certain mass, and if I were to count this number of particles, it would be 6.022 times 10 to the 23rd. All right, so if I have a mole of quarters and I were to weigh it, obviously it would weigh quite a bit. Okay, well, when we talk about the mole, we usually talk about very tiny particles, in particular atoms. So we're going to talk about the molar mass of atoms. All right, and if you look on your periodic table chart, okay, if you look at helium, let's take helium as an example. Helium, the atomic mass of helium is 4.003, okay, grams. That's the atomic mass, okay? Okay, great. Well, 1 helium atom doesn't weigh 4 grams. 4 grams is quite a bit, especially if we're talking about 1 helium atom. So how many atoms do you think weigh 4.03 grams? All right, how many atoms do you think weigh 4.003 grams? Well, if you said a mole of atoms, then you are correct, which is 6.022 times 10 to the 23rd. So if I were to count out this many helium atoms, we would call that a mole, and this is how much it would weigh. All right, so this many atoms, Avogadro's amount of atoms, weighs 4.003 grams. Okay, let's say I were to measure out carbon atoms. Let's say I measured out a mole of carbon. First of all, how many carbon atoms is it? 6.00, I'm sorry, 6.022 times 10 to the 23rd. That's how many, if I were to count out that many carbon atoms, it would weigh 12.011 grams. How did I know that? Well, I looked on the periodic table. Okay? So your periodic table so if you look at this, these are looking like conversion factors, aren't they? It takes information of one thing and it converts it into something else. And it's an equality of some sort. Okay, so your whole periodic table are conversion factors. So let's take iron. Okay, If I were to take a mole of iron, let's say I took 1 mole of iron. First of all, how many iron atoms is it in 1 mole of iron? How many atoms? Well, 6.022 times 10 to the 23rd. All right, and how much do you think it weighs? If you were to weigh all those iron atoms, well, if you said 55.845, you would be correct. Okay, so 1 mole of any atom or element, whatever element you're talking about, if you take a mole of it, if you're talking about a mole of it, this is how many of them you're talking about. So a mole of gold is this many gold atoms. How much does it weigh? Well, it would weigh 196.967 grams. Okay, your atoms are all different sizes. They have a different number of protons and neutrons and electrons and shells. All right, all right. So they all weigh a different amount. Okay, well, how can you weigh one atom? If I were to have 1 gold atom, how would I weigh it? Yeah, it's impossible. First of all, I can't even hold it. I wouldn't even know I even have it. And second of all, I can't weigh it. Well, but I could weigh a mole of it. If I had a mole of it, this is how many atoms I have. That I can actually see and feel and touch. That I can weigh, and this is how much it weighs. So all of the atomic masses on the periodic table are based off of 1 mole of that substance. So 1 mole of chlorine weighs 35.453 grams. And if I were to count the chlorine atoms, this is how many chlorine atoms I have. Okay, so hopefully this kind of makes sense. So 1 mole, okay, of any element, all right, equals the atomic mass. Okay, and it's also equal to this many number of atoms. Okay, this is a conversion factor that you have to remember, okay, and kind of know, because this is what we're going to be using quite a bit. All right, so I kind of just did everything for you on this page. So it's counting atoms by weighing and converting between mass and moles. So let me talk about that, the conversions. Let's talk about conversions and maybe do a problem or two. Okay, so 1 mole of anything, I'm going to kind of give you like this little cheat sheet, I guess, is the number of atoms, and then here's, and this is the mass in grams. All right, mole is kind of our central theme. We can get to everything from the mole. If I want to get from, so here's a problem. I'm going to give you a problem. How many grams are in, I don't know, let's say 15.2 moles of helium? Okay, how many grams are in 15.2 moles of helium? So this is our given quantity. This is my given quantity is moles. I'm given moles. Let me erase this one. That one shouldn't be there. I'm given moles, and I'm trying to get to mass. Okay, so this is where I'm starting in my equation. The way I do it is by using the atomic mass. Okay, the way to get from moles to number of atoms is I use Avogadro's number. Okay, so how do we do these problems? Okay, it's just like what we learned in chapter 4. First, write your given quantity, 15.2 moles of helium. And I'm going to multiply that by some sort of conversion factor where moles is on the bottom and grams is on top. How do I know that? Well, moles is here. I need moles to cancel out with moles, and I'm trying to get grams as my final answer. So do I know a conversion that converts moles to grams? And I sure do. 1 mole of any element is its atomic mass. So what's the atomic mass of helium? Well, it's 4.003. So this is my calculation. This is my conversion factor right here, because 1 mole of anything is the mass of that element. So basically, I'm taking 15.2 and multiplying it by 4.003. All right, so 15.2 times 4.003 equals, and you got to have the correct number sig figs, 3 sig figs, because 15.2 has 3, so 60.8 grams. If I had 15.2 moles of helium, it would weigh 60.8 grams. All right, this is how we do these conversion factors. All right, let me do one more for you. I believe there are a bunch of practice problems at the end of the slide, but let's just do it now just so we can do it. And what I'll do is I'll kind of put it up here. Okay, so you saw the whole entire process. The process is pretty straightforward. Start with where you're starting and go to where you're ending. So, how many atoms are in 55.5 grams of gold? How many atoms are in 55.5 grams of gold? So here's my starting point, my grams, and where am I getting to? Number of atoms. I'm getting to here. I don't want moles, I want atoms. But in order to get to this, I have to get to moles first. So I have to go from my mass, my given quantity, to moles. Once I get to moles, then I got to use Avogadro's number and get to the number of atoms. So why don't you put this on pause, do the problem, and then come back and I'll do it for you. Welcome back. If you didn't hit pause, do it now because I'm going over it. Okay, first of all, write what your given quantity is. Our given quantity is 55.5 grams of gold. Okay, well, I got to convert that to moles. How do I do that? The atomic mass. That's my conversion. So what has to go on the bottom? Moles or grams? Well, your grams has to go on bottom because your grams is on top here. So gold weighs 196.967 grams is to 1 mole of gold. That's AU for gold. Okay, so grams cancels with grams, you're left with a mole of gold. All right, well now I got to convert to atoms. Well, that's Avogadro's number. 1 mole of anything is 6.022 times 10 to the 23rd. Okay, and that it equals 1 point, you're going to round here, so I get 70 times 10 to the 23 gold atoms. All right, my calculator says 1.696, so that rounds the 9 up to a 0, which rounds it up to 1.70. Okay, so that should be your answer. All right, just to make sure you understand the process. This is kind of a cheat sheet type of thing. It's not really a cheat sheet. It just kind of shows you how to get from one thing to another. Mole is always our central concept. Okay, in order to get from mole to grams, you use the atomic mass, the periodic table, because 1 mole of any element is the mass of the element. If you want to get to number of atoms, to go from moles to atoms, you use Avogadro's number. All right, there's more practice problems at the end of this, and then as well, we'll do a lot of practice problems in class. Actually, here's some more sample problems. Tell you what, once you go through these, there's 3 sample problems. One is determine the number of moles of carbon in 25 grams of carbon, number of moles of helium in this many grams of helium, and the number of moles of sodium. So you'll get quite a bit of practice. Put on pause, do these practice problems, and then you can look back at the slides because I believe the answers are on the slides. All right, so go to it. All right, so the answers are on the slides. You can go through this, but basically it's the same thing. It's using the molar mass, taking however many grams you have and basically multiplying it by 1 mole divided by the atomic mass to get the number of moles. Okay, your book kind of gives you this chart. I think this is confusing. All right, if you compare my chart, now my chart's not as neat, but this is the chart. This is the chart that they are trying to kind of show you. Moles to mass and moles to number of atoms. They show you the same thing here. They're showing you moles to mass. They're actually showing you the calculations. And then moles to atoms are showing you the calculations. If this makes more sense to you, by all means, go ahead and use it. Or memorize this list. But I think that the list that I had, basically all they're showing you is moles is in the center. You get to the number of atoms, okay, by using Avogadro's number. And then to get to the mass, the grams, you use the atomic mass. Okay, hopefully this makes sense, but like I said, we'll do a lot of problems in class. All right, here's some more sample problems. These are now going from grams to number of atoms, or from going from number of atoms to mass. So put on pause, do these, And when we're done, I'll flip through the slides, but like I said, you have access to the slides so you can find the answers. Okay, welcome back. If you didn't put on pause because I'm about to flip right now to show the answers. Here we go. Okay, so here is from going from grams, number of atoms. This is like a problem that we did. You have your grams, multiplying it by the atomic weight of carbon, which is 12.01, and then multiplying it by Avogadro's number. All right, here you're starting with number of atoms. All right, you divide it by Avogadro's number and then multiply it by the mass. So this really doesn't weigh that much if you think about it. If you think about how many atoms this is, that's a lot of atoms, but notice it's 0.000458, really small amount of mass. All right. Okay, that's the end of section 5.1. So I will see you on the next video at 5.2.